Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so we have hydrogen fluoride, HF, is used in the manufacturing of refrigerants, herbicides, and pharmaceuticals, and gasoline. Hydrogen fluoride can be prepared by treating calcium fluoride with sulfuric acid according to the following balanced equation. Then 3.1 says draw a Lewis diagram for HF. So to draw that one, it's pretty simple. You have your hydrogen with one valence electron. So indicate the valence electron of hydrogen. Then we have fluorine, which has 7 valence electrons. So we have 1, 2, 3, 4, 5, 6, 7. And just like that, we can see that now we have a complete orbital with fluorine having 8 electrons around it, and then hydrogen only having a 2. Remember, the hydrogen is an exception. It only needs a maximum of 2, a maximum of 2 electrons in order to fill its orbital. Then for 3.1.2, this one you need to be careful with it. So the first thing that you do when drawing this one is you have to break it down into ions. So when you break this down to ions, it becomes Ca. And then since our calcium here is in group number 2 with 2 valence electrons, we say it must give off those 2 valence electrons. Hence, we end up having 2 plus there to indicate that the calcium will have to give away or give up its 2 electrons, right? But then with the fluorine has 7 valence electron, meaning it's not at the position to give away, but it's at the position where it has to gain in order to become a stable atom, right? So the ion there will have to be indicated as F to the exponent of -1. The -1 here, or if we just write it like this, the 1 minus, so it's simply telling us that it must gain 1 electron. So it needs to gain an electron in order for it to have a complete orbital, right? Then this is how now we have to draw that one. So indicate this. Remember, we indicate this if it's an ion, right? So the square bracket means that we are putting in an ion inside. Then Ca2 plus. So note that there will not be any valence electrons, because if it gives away its 2 electrons, that means it is left with an empty orbital, right? So it only has those 2 valence electrons. So if it gives away those 2 valence electrons, that means we are not left with anything there, right? So again, the 2 plus needs to be there. Excuse me for that. So we need to indicate our 2 plus or plus 2 here. And then again, we have to show for this one. For the fluorine, remember the fluorine is not giving away its electron, it's gaining. So we need to put the fluorine here. Originally, fluorine has 7 valence electron, but then if it has to gain 1 more electron, then at the end of the day, it will have a complete orbital of 8 electrons. So we need to say 1, 2, 3, 4, 5, 6, 7, which would normally be the number of fluorine or of the electrons that fluorine would have. But then remember, the 1 minus there is indicating that it gains an electron. So when it gains an electron, it ends up having a full orbital, right? So that's 8 of them. Now, you do not necessarily have to indicate it with a different color. I'm just trying to show you what actually happened, right? And then here you indicate the minus there. But then one thing that you also need to figure out is that we have 2 atoms of fluorine, right? So now that we have 2 atoms of fluorine, remember, this will happen to each and every fluorine atom that we have. So that means we need to indicate the 2 here, to indicate that the fluorine here will have to gain an electron, but then also we have another fluorine which the process will be repeated. So all in all, to draw a Lewis diagram for this molecule here, that's how you do it. You put your calcium here without any valence electrons, because remember, it just gave away 2 of its valence electrons. And then this one here, it's not giving any valence electrons, but then it's gaining. So now if you can think of it, you can say that the 2 valence electrons that have been given, they go to your fluorine. So your 2 atoms of fluorine, one has been accepted by this one atom of fluorine and the other by the other fluorine. Right. So all in all, that's the sharing of electrons that takes place in this molecule. Then let's now proceed to 3.2. It says define a polar covalent bond. What is a polar covalent bond? So we say a polar covalent bond. So the definition that you're expected to write is a polar covalent bond is a bond in which the electron density is shared unequally between the 2 atoms. Between the 2 atoms. So if there is an uneven share of the electron density, we say that we have a polar covalent bond, right? So a polar covalent bond, so here a polar covalent bond is a bond in which the electron density is shared unequally between the 2 atoms. Now you can also have another definition whereby you say it's a bond between 2 nonmetals where the difference in electronegativity is more than 1. Right, so can also say is a bond between 2 nonmetals where the electronegativity difference is more than 1. So this is what I used to actually prove that last question on the previous video that I made. So you can also say a polar covalent bond is a bond between 2 nonmetals where the electronegativity difference is more than 1. So if the electronegativity difference is more than 1, we say that we have what we call a polar covalent bond, right? Then let's proceed. We have 3.3 says which one of the 2 products of this reaction would most likely be a gas at room temperature. So which one would be a gas at room temperature? Then what will be a gas at room temperature is our HF. Remember, they say this is used to make the refrigerants, herbicide, pharmaceutical, and gasoline. Now, we know that something that makes a gasoline has weaker intermolecular forces. So, therefore, we expect it to be a gas at room temperature. Then 3.3.2, which one will be a crystalline solid at room temperature? Now, the one that will be a crystalline solid at room temperature will obviously be our calcium sulfate, right? And then 3.4 says define the term electronegativity. So how do we define electronegativity? We say electronegativity is a measure of the tendency of an atom in a molecule to attract bonding electrons. So for 2 marks, that's how you are expected to define electronegativity. Is a measure of the tendency of an atom in a molecule to attract bonding electrons. Right. Then let's proceed to 3.5. It says use electronegativity to determine the type of bond that will form in calcium fluoride. right? So use electronegativity. Then in 3.5, this is what we are going to say. Change in En is equals to the En electronegativity of, so we have to figure out, number one, between the calcium and the fluorine, which one has a higher electronegativity. Then if we check there, our fluorine has an electronegativity of 4.0. And then we have our calcium. Where is our calcium? Here. And then with an electronegativity of 1.0. So which one are we looking for? So the type of bond that will form in calcium fluoride. So if we say the En of the fluorine minus the En of the calcium, then we get the difference, right? So we are supposed to say this is 4 minus 1.0. So 4.0 minus 1.0, which is just 4 minus 1. So 4.0 minus 1.0, that's going to give us 3, right? Now, if we get 3, we know that this means that it is an ionic bond, right? Do they say greater than 2.1? It is ionic bond, right? And then 3.6, they say, will HF be a polar or non-polar molecule, right? Now, based on this, should it be a polar molecule or non-polar molecule? Obviously, our change in En is greater than 0, so which makes it a polar molecule, right? Because we say there is an uneven distribution of the electron density. Then for 3.7 says, explain the answer to question 3.6 using a calculation, right? So for HF, so the calculation that we are supposed to use again is the electronegativity difference. That's really the only calculation that we have here. So En of fluorine minus En of hydrogen. Now the En of fluorine, we already saw it is 4.0, but then the En of the hydrogen, let's check, hydrogen is 2.1. So when we are talking electronegativity difference, these are the numbers that we see here. So do not be confused, these are the numbers that we see here, right? Then if we say 4.0 minus 2.1, we get our value as 1.9, which is suggesting that this is polar, right? So it is a polar molecule. So it has polar bonds, and therefore it is a polar molecule. So polar bond, polar molecules. Then that's how you were supposed to actually go about answering this question for a total of 15 marks. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, what are you waiting for? Please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.